So we go through this few concepts. Please learn the concept. It's not about the question. It's always about the concepts that you learn while we are doing the revision. So please feel free also to ask as many questions as you can on any concept. First thing is algebra. Now determine the value of x for which that expression, okay, we'll be defining a few things, has real values. Number 1.1.1. When we say real values, when will this have real values? Real values are values that exist, and if there's a square root, it means that whatever is underneath the square, let's call k, it means k should be greater than or equal to 0. If I can have that greater than or equal to 0, then it's going to be real. For it to be non-real means error, no solution. All right? It means k would have to be less than 0. We cannot find the square root of a negative number. Let me know, before I even give you answers, is that making sense? Please, do you understand the word real? I need us to be prompt with this. Real means when I punch this in a calculator, I must have an answer. And for me to have an answer, whatever is underneath the square root must be 0 or greater than 0. So for this to be 0, please check. So I'm going to do a bit of extensive explanations on each of them. Look, don't worry about the numerator. I'm going to tell you how numbers behave. X squared will always, remember, it's not just about the question, it's about principles, will always be positive, no matter what the value of x is. As long as I square a number, that number will be positive. So let's take note of that. You need that knowledge. It means my numerator is definitely positive. Now I have a denominator. Do you notice that I want 9 minus x to actually be I want everything there to be greater than what? 0 or equal to 0. Basically greater than 0 if you want real values. So what do we say? My denominator must be positive, so that positive divided by positive will be what? Positive. So 9 minus x must be greater than what? 0. Minus x must be greater than negative 9. What do we do? X must be when I divide both sides, x must be less than 9. For any value where x is less than 9, I'll have an answer. That's what we're saying. For any value where x is less than 9, I'll get an answer. Did that make sense, everybody? I want this whole thing to be positive, the square, so that I can get the square root of a positive value. If the top is already positive, my bottom cannot be negative. So my bottom must also be positive, right? And if we say something is positive, it is greater than 0. Then we solve for x. Remember, when I divide by a negative, my inequality sign changes. Is number 1 okay with you? Okay. Number 2 quickly. Non-real. Okay. 1.1.2. For something to be undefined, please take note, whether paper 1 or paper 2, your denominator should be equal to 0. As long as your denominator is equal to 0, whatever it is will be undefined. So I just look at my denominator. 9 minus x equals to 0. Move the x over. X equals to what? 9. Done. Undefined concept. Denominator must be equal to 0. I hope everybody is done. I hope we are okay. Talk to me. Can I go to number 1.1.3? So please, it's not about the answers here. It's also about the concept. That's why I'm writing little notes for you there. So the notes are mathematical. You need them. Can I continue? Can I get your thumbs up? Okay. Please remember, you can always call me back. What are we looking for now? Given x is 1, is the expression rational or irrational? Quickly again, what are rational? Rational is a number that can be written as a fraction. Okay? And since I have a square root, introducing the square root, for this to be a rational number, it means I must have a perfect square there. If I have a square root, I must have, for example, look at it, let's try. If I tell you what is the square root of, let me write it here. What is the square root of 4? 4 is a perfect square, so that's 2. But if I tell you the square root of 5, 5 is not a perfect square. You won't be able to write this as a fraction. Let's check on a calculator. Square root of 5. You see, it's not giving us a fraction. And if that's happening, that means it is an irrational what? Number. So, irrational. We're talking about decimals. Numbers that can only be written as decimals. And if it's a square root, if there's a square root there, we're going to say a non-perfect what? Square. Okay, information enough now. For example, the square root of 5. Okay, given x equals to 1, what are we going to have? 1 squared plus 4 over 9 minus 1. What will this give us? Do you think this is rational or irrational based on what I just explained now? Do you think it's rational or irrational? Based on what I just explained. It's irrational because 5 is not a perfect square, 8 is not a perfect square, so this is irrational. Are we okay? Determine the value for x where the expression is a recurring value. A recurring value. I'm moving on quickly, so make sure you're writing as quickly as possible. You can also rewatch this, and like I said, it's more content now. A recurring decimal, you know what it means, right? That the number keeps recurring. Look, what comes to mind quickly will be things like 1 over 3, because that's 0.33333. Another example, 2 over 3, right? 0.66666666. So those are basic numbers. Anything that would give me this, 1 over 3, 2 over 3, these are just few examples. So I could have 4 over what? If I multiply this by 2, I could have 2 over 6 would work. I could have 4 over 9 because I'm just multiplying by 2. But let's see what this one is looking like. We've got to be smart here. X squared plus 4 over 9 minus x. Oh, look at what I did here. I already see my answer. Can you see there's a 4 and a 9? Aha, done. because 4 over 9 would give me 2 over 3, and 2 over 3 is 0.66. So how can I get rid of this? Oh, if x is 0, that would work. 0 squared plus 4 over 9 minus 0 would give me that. Now look at this number. 4 is a perfect square. 2. 9 is a perfect square. 3. But 2 over 3 is a recurring decimal. Do you see that? But it's rational. It's a recurring decimal. Therefore, examiner is just stating a few grade 10 stuff here. When x equals to 0, I'll have a rational, I'll have a recurring decimal. Are we okay, everybody? Are we okay? Please let me know. You want to come back, we stay on this, solve it, get the knowledge involved, and move. So take note of all the definitions I'm giving you. They are very, very important. X equals to 0. Thank you, Space Sitley, for giving me that answer. X equals to 0. Look at this one. 1.2.1. What are we solving? I think this one is straightforward. 2x squared minus 3x. K is 5. Guys, do you know how to factorize? Please. That is very, very important. The examiner wants you to know how to factorize. If you don't know how to factorize, please listen to me carefully. 30 seconds, you should be done. Look at this equation. 2x squared minus 3x minus 5. Multiply this. I love this method. Multiply the 2 and the 5. What do I have? You see, I have removed that one. 2 times 5 is negative 10. So I have removed my 2. Now this we started doing in grade 8 or 9. This is very easy to factorize. It's x here, it's x here. Product of 10, 5 and 2. But I want a negative 3. So the bigger number should be negative and the smaller number should be positive. 2 minus 5 would give me negative 3. Now look at what I did. I multiplied by 2 first. So I'll come back here and divide by 2. If you don't like this method, just find a method that works. Now this is x minus 5 over 2. I'm simplifying. 1. But I won't leave my answer like this. You see this 2? I'm going to bring it here. So it becomes 2x minus 5. Now that's what I'm going to write here. That's where the mark is. 2x minus 5 x plus 1. Please, you need to know how to factorize. Whichever method, whether you want to turn, I can also use another method to turn it into a coordinate, whatever it is. The day must not end today without you knowing how to factorize. So, 2x minus 5 equals to 0, or x plus 1 equals to 0. What is x? 5 over 2, and we are done. Negative 1. Everyone must please know how to factorize. Now the next one, 2x squared minus, they said k equals to 4. Once I see correct to 2 decimal places, please understand that I'm simply using my what? Quadratic. Minus b plus or minus, and you would not be given a formula page, so I'm expecting you to know this formula. Minus b plus or minus. Please show your substitution. So I'll come here and say my a is 2, my b, don't forget the sign. So what is x? Minus b, use bracket, plus or minus square root of b squared minus 4ac over 2 multiplied by 2. You want to supply me with answers here, please? I need answers for this one. Everybody is working. Remember, guys, if you are lost, please don't keep quiet. Two comma 35. Can I have somebody backing that answer up? Two comma 35, or is it negative? Negative 0.85. Somebody backing that answer up? Okay, let's see. All right, Specitli has given me an answer. Tejo has given me an answer. Kutwano. Okay, you guys are giving me the same answers. Please, if you are not sure, Lindy, I didn't get answer from you, so I'm not sure whether you are waiting for us to do it or you did calculate it. Lino, I'm not sure. Soli, please, are we agreeing? Did you do it? Did you punch it in a calculator? Please, no one is allowed to get these marks wrong. I'm begging you. 2.35 or negative 0.85. Okay, very straightforward things here. All right, so for x, we have surds. I don't know if you guys remember the 5 steps of solving surds. 5 steps of solving surds, and you will see it's 5 marks. Number 1, isolate the surd. The surd is the one with the root. Number 2, square both sides. Number 3, expand and simplify. Number 4, solve for x. And number 5, you must test your answer. For validity. You cannot escape these questions. So please get the step once now and for all. So I'm doing my 1.3.1. X minus 4. The beauty of this is already isolated. You see, step 1 has already been done. And if you think you're going to be confused, look at, I could just take that whole thing, I can change sides. But it's not necessary. So, step 1, the surd is already isolated. Step 2, square both sides. So I'm going to, when I say square, please include in the negative. Only square when you have an equal sign. Now, what do I have here? X squared. We are not distributing, please. Plus 16. I hope you know how I got that. Now, on the right-hand side, negative times negative is positive. Then the squared and the square root will take care of each other. So I'm left with x minus 2. I want to pause and ask if you are okay. Are we okay there? So now we can simplify. Bring everything over. X squared minus 8x minus x plus 16 plus 2. What do we have? X squared minus 9x. What is this? 18. Now what are we factoring? We're factorizing, right? Factors of 18 are 3 and 6. That would give me, yeah. So minus minus. It's either x equals to 3 or, that is step number 4. You have to do step number 5. And what is step number 5? You test. And where do you test, guys? You test in the original. Let me show you how to test. So I'll grab my calculator and put on the left hand side. Let me quickly show you with the calculator. For the first one, I'm testing x equals to 3. So if I say 3 minus 4, My answer is negative 1 on the left hand side, right? I'll go now and put x on the right hand side. I must also get negative 1. So check, negative square root of 3 minus 2. So my left hand side is negative 1. My right hand side is also negative 1. That works. X equals to 3 works. What about 6? Okay, left hand side, 6 minus 4 is 2. Left hand side. Now let's go to the right hand side. Negative square root of 6 minus 2. Negative 2. It's not working. I have to come and say, x cannot be equal to 6. Please don't forget, every time you get to surds, remind yourself, oh, Sir said it's a 5-step ruling. Are we good? Are we good? I'm working at a fast pace because I want us to see if we can get some extra questions. Now, the next one is inequality. A lot of people also struggle with this, but I want you to listen to me. Greater than 3x. First thing, make sure the right hand side is a 0. Please don't just change the signs. You only change signs when you divide by a negative. I only moved things over. So please, my sign is not changing. Let's simplify. X squared. What is 4 minus 2? Good. Now, do you see why you must learn to factorize? It's always there. There's no way you are going to run from it. What are the factors of 2? 2 and 1. But what do I want? I want a negative 3. So minus 2 minus 1. Now, from here, please, my good learners, from here, I don't want you to see any equal sign in your working. Please, don't write any equal sign. Just come outside of your book or your page and say critical value. X minus 2 equals to 0. X equals to 2. Or x minus 1 equals to 0. I don't want to see this here. All right? I like to use a number line because it's easy for me. My critical values are 1 and 2. Write the smaller number on the left and the bigger number on the right. Please listen. If this is written in standard form, and I'll tell you what the standard form is. What do I mean by standard form? That is, x is positive. You will notice it's positive x and positive x, right? That's the easiest, standard form. You know what I'll do? It's a plus, it's a minus, it's a plus. That sign will not change as long as that thing is a positive sign. I have some videos, although they're quite long. Everything algebra. If you have time, go and watch it. I dealt with anything called algebra in those videos. It's called Everything Algebra, grade 11 and 12. Now, what am I looking for? I'm looking for things that are greater than 0, which means they are what? Positive. Oh, so those are my positive. Things that are positive are on the side. From 2 going up, from 1 going down. So x is less than 1, or please, some of you like combining, and you are combining wrongly. When will I combine? My good learners, please check. I'm going to do some other examples. If I have a less than 0, what's my critical value? 1, 2. Again, standard form. Now, if I want something less than 0, it's a negative. Where is that negative? It's right here. It is in between 1 and 2. It is between 1 and 2. Look at, that's when I combine. When a value is in between. It's also going to come in functions. Please talk to me. Let me know if you are okay, because I want to do one more example. Let me know. Ask questions. I want to do one. Can I move here? Now, let me do something for you. I want to give you a question. What if I have a question that looks like this? Because we spoke about standard form. What if I have a question that looks like this? Minus x plus 2, x plus 3. What would you do here? Do you want to try this for me 2 minutes? I want to see something. Try this for me 2 minutes. Let's see what you will do. I want to see from the knowledge you guys have. Quickly. Okay, my good learners, please watch. This is not in standard form. For it to be in standard form, I told you x must be positive. So here's my problem. And all I'm going to do is apply sign change. Look at what I'm going to do. I am going to multiply this first bracket by negative. So it's going to be, the signs will change. The negative becomes a positive, the positive becomes a negative. Once I do that, okay, this one is fine. I have to change this inequality sign. Now I have it as standard form. Critical values, small number on the left, because it's negative 3. Once I have that, plus, minus, plus, what am I looking for? Greater than 0. X is less than negative 3, because it's that. Or x is greater than 2. Are we okay with that? I wanted to make sure you guys understand what I mean by standard form. Please try one more for me. Try that for me. We are moving on from here now. We need to go to now what simultaneous and nature of roots. Okay, can you hear me? My mic was off. Can you hear me now? All right. I said I noticed that my brackets are not in standard form. So the first thing is to write them and write them one after the other until you understand fully. So I'll change this. It must be positive x. Can you see I've changed it? Once I do that, my inequality sign changes. Keep this one for now. Change it one after the other. Now I can change the second one because I need it to be standard form x first and positive x. Now my inequality will change again. Every time I switch, my inequality sign also changes. Oh, critical values 2 and 3. Remember, positive, negative. I am looking for things that are less than 0, which is negative. My answer is between. Can you see when I'm combining? I'm combining when my answer lies between. Please take note. Don't just combine anyhow. Is everybody okay? I'm moving away from here. Questions? I'd love to take your questions. If there's no question, we're moving quickly. Yes, Lino? Lino, I'm listening to your question. Yeah, I used the sign change rule, Lino. That's what I used. 2 minus x is negative x minus 2. That's sign change. Once I switch them, it's sign change already. So we just switch them and you don't need to show the minus. Sign change rule. Okay. All right, guys, let's do this quickly. Now, this is nature of roots. Nature of root. Tseho, you asked for nature of root. When I finish also, I'll send you a link. You'll just remind me. I've got another video about 45 minutes or so there where I fully explained nature of roots again. It might also help you because here we won't really have much time, but I'll go through it. All right, what are we saying here? We're saying, wait, didn't I jump? Did I jump a question? Where's my 1.4? Okay, but it's fine. We'll come back to 1.4. It says, for which values of p will that have 2 unequal roots? Okay, look, let me quickly do this for you. Nature of roots, quickly, 5 minutes. Roots are either real or unreal. They are either real or non-real. For them to be non-real, my discriminant must be less than 0. Remember, discriminant, x equals to minus b plus or minus square root of what? Discriminant. Your discriminant is what is underneath the square root, which is b squared minus 4ac. If it is a negative, then it's a non-real root. For it to be a real root, it must be greater than or equal to what? 0. Now, this one can be divided into 3. What do I have? It's either real and then equal. For it to be equal, discriminant is equal. Same language. Equal roots, I change that to equal sign. Unequal, my discriminant must be greater than 0. And for it to be rational, my discriminant must be a perfect square. You just understanding this alone, you are 95% done with nature of roots. Just this little explanation, you're good. All you need to do is to figure out b squared minus 4ac. Okay? Teho, Fatu, this is your nature of roots. It's as simple as that. It is as simple as that. So let's answer this question now, quickly. Let's answer this question. I hope you're ready. Can I move to the question, guys? Can I move? And sometimes you can actually sketch the graph. It's always also nicer when it is touching. I think I did this some days ago or so. When it is touching, then it means that touching once, you see that point. We did this. I remember sketching these graphs. two equal roots, we have that. x1 and x2 are different. If it's rational, we are going to have the same. The graph is going to touch also once. If it is non-real, the graph is not touching at all. So those are your graphs. Sometimes graphs are easier to work with. Okay, but anyway, I want to run. Can I run with a question? Okay, let's answer now. No. All right, for which values will this? Guys, before I answer the question, I have to say it is equal to 0. So that my A is -2, my B is +4, and my C is that. Okay, ax squared plus bx plus c. Arrange them. They said two unequal roots. Oh, beautiful. Discriminant is greater than 0. B squared minus 4ac must be greater than 0. What is our B? 4 squared minus 4 minus 2 minus 3 plus p. Now we solve for p. This is 16 minus 4 times minus 2 minus 8, so that you guys can see what's going on here. Learners get confused with that. Now what do? I open minus 8 minus that will give me positive 24 and minus 8p greater than 0. What is 16 minus that? Remember, my sign is not changing. 16 plus 24 would give me what? Will minus, yeah. So what will 16 plus 24 give us? Somebody, 40. Now if we move the 40 over, it becomes -40. Now if I divide by negative, what happens? The inequality sign changes. Please, let's check if we are okay with this. B squared minus 4ac. Wait, something is wrong here. This is a positive. Negative times negative is positive, yeah. I just noticed that something is wrong. Negative times negative is positive. Okay, 16 minus 24 plus 8p, yeah. So 8p is greater than, this is minus 8. Okay, p should be greater than, no, positive 8. P should be greater than 1. Sorry, my bad. Negative is positive. Are we all right there? Are we all right? Okay, next one. I want both roots to be positive. What it means is I want both x values. Look at what we mean here. Let me show you something here. I want both roots to be positive. It means when I sketch this graph, okay, because my A is negative, right? It's a sad face. I want my graph to be like this. No, sorry. Both should be positive. You move. This graph must, when I sketch this graph, I want it to be like this. Roots, x1 and x2, positive roots. I want those to be what? Positive. Now, how do we manipulate this? Let me use my turning point to tell you, if I want this, what do you notice? Look at my turning point. My turning point is positive, right? Minus b over 2a. must be greater than 0. But I already see something that my A is less than 0, right? My A, as this question is, my A is less than 0. For me to have a positive, it means B also must be what? Less than 0. Does that make sense? No, B must be greater than 0. What do I mean? Let's check something. It's negative. That's with the formula 2. My A is negative in this question. And negative divided by negative is positive. So this must be positive so that this is positive. Once this is positive, my turning point will be on the positive side, which most likely makes that so. My 2 roots would be close at least to the positive side. If my turning point is on the negative, there's no way this graph can, do you see that? There's no way. So most importantly, my turning point must be positive. But how do we infer to this guy? If we go back to b squared minus 4ac, remember we still want it to be greater than 0, but we are saying in this case, what is our b? Our b is positive, right? Just want to see how we can manipulate this. Our b is positive already, okay, and a is negative. So p must be greater than 1. Okay, 1 second. All right, so if we look at this graph at the moment, just want to quickly see something here. If we look at this graph at the moment, sketch it. Oh, I want a red. If I sketch this graph at the moment, our graph is what? Negative 2x squared plus 4x minus 3 plus p. Sad face. What is our b? Minus turning point minus b over 2a. Just want to check something quickly. Minus b over 2a minus 4. Okay, everything seems to be working well. This would give us negative, negative. So my graph is turning at 2. All right. And my c really doesn't. Does it matter? Does it matter? Okay, please watch this. We have to deduce. If my c is greater than 0, look at the graph. Please watch. If my c is a positive, then the graph would look like this. Does that make sense? Oh, this is very interesting. Everybody look at that graph. If my c is positive, do you notice that I'll have one negative? Let me come to this page. I love this. I love this. I love this. This is very, very unique. Okay. We said our A is less than 0. B is greater than 0. So minus b over 2a. B is positive. A is negative. This gives us a positive, which means my graph is turning here. But I want the 2x intercept to be on the positive side. Look at this. Right? If my c, at this point, my c is 0. But if my c, watch this, if my c becomes a positive value, do you notice that the graph is now defeated? Please let me know if you understand. If my c becomes positive, remember c is the y-intercept. I'll be getting a negative and a positive, which is not what I want. Does that make sense? Please talk to me. Does that statement make sense? If my c is positive, then my x1 and x2, one will be positive, one will be negative. I want both of them to be what? Negative. So the best one is to have it like this. That my C value must be what? Negative. Interesting. Then I'll have positives there. Do you see, graphs are important. And what is our C value? Minus 3 plus P. It must be negative. Beautiful question. I love this. So C must be less than 0. Minus 3 plus P less than 0. P less than what? 3. But we are going to link this to the first question. We said P must be greater than 1. So P must be greater than 1, but look at P must be less than 3, but greater than 1. So it is in between those two. Oh, this is such a beautiful question. This is actually testing if you understand functions. P must be less than 3, but it cannot be greater than 1, because we said for real root, P must be greater than 1. Beautiful question. I love it. I love it. Please let me know if it makes sense. We're doing much of algebra because functions we did not too long ago, so it's still fresh. We just need to do hyperbola. So please understand graphs, understand what I drew to do the graph. You know, it makes a lot of sense. It makes a lot of sense. And understand how to interpret your A, your B, and your C. Beautiful. Please watch this again so that you'll be fine. Look at this one. Show that the equation that equals to that has no real root. Again, when they say no real, understand, what are they saying? It means your discriminant is less. So they say we should show. We're not looking for. All I need to do is to look for discriminant. But I cannot look for discriminant until I make this equation. See, I'm bringing that. What is your A? P squared plus 1. What is your B? The coefficient of X. And what is your C? Let's look for discriminant. You see, I'm not saying less than 0, but that's the condition I want to have. What is my B? 2pq squared minus 4. What is A? P squared plus 1. What is C? Q squared. Let's solve. 4 laws of exponent. Okay. Minus. Please be careful of how you solve this. You can do this first, or you can say 4. You have q squared there. Right? Now you can expand 4p squared q squared minus 4p squared q squared minus 4. What do you notice here? That's 0. So our discriminant is negative 4. Now, how do you interpret this? For when q is that, q squared is always positive, right? But my discriminant is negative q squared. If this one is positive and I'm multiplying by negative, so it's less than 0. Can you see I've gone back to that? For all values of, so it's non-real. So we're saying negative 4q squared is less than 0 for all values of q. Interpretation. Anything squared will be positive, but I have a negative in front of it, which means the final answer becomes negative. Are we good? Don't tell me I jumped simultaneous in this paper. Everybody okay? Did I jump simultaneous? Yes, I did. Never. Let's fetch it. We need to fetch that simultaneous quickly. 1.4. 6 marks. Very, very important. I'm going to run through this simultaneous. How do we solve our simultaneous? 2x equals to y plus 2. From here I can find y. It's very easy to find y. I have 1 mark. Then I'll throw y into my equal. Please don't rush this. If you are not sure of what to do with this negative, you can bring it over. If you bring it over, what do you have? Y squared. Do you see that, right? Plus 2x squared plus 2. Now what is y? Y is 2x minus 2 squared. Common error is that learners then distribute instead of foiling. 2x times 2x is 4x squared. 2x times negative 2 is negative 4x. Now I have to multiply that by 2. I hope you guys know how to foil, please. If you don't know how to foil, let me know. That I cannot allow you to go today. I did not distribute, I'm foiling. So I'll do it again. The simplest way is to say the first one squared, 4x squared. Look at the last one squared. Now what's in the middle? I'll say this multiplied by this multiplied by 2. 2x times negative 2, negative 4x. Multiplied by 2, negative 8x. That's the simplest way. 4x squared plus 2x squared, 6x squared, minus 8x, plus 4 plus 2. I think we can divide by what? 2 to make life very easy for us. Or you can just use your quadratic, but I'll divide by 2. (3x squared minus 4x plus 3). Now you need to know, like we said, you must know how. There's an error here. This is minus. Guys, you guys are not talking about my errors. 4 minus 2 is 2. Okay, now we can factorize quickly. Again, I'll do my own method. I'll multiply by 3. It's easier for me. I just love that method. X minus 3. So I multiplied by 3. Now I'm dividing by 3. This is x minus 1. Beautiful. This one I cannot simplify further. So I'm done. X minus 1. 3x minus. Please make sure you write this equal to 0. Please. If you don't write that, you are losing marks. Now what do? I substitute back. Show your substitution. Or this gives us 2 over 3 minus 2, which is 2. What's the answer there? My head is tired. 2 over 3 minus 2. That is 6 minus that. Negative 4 over 3, I think. Please confirm for me. Yeah. 2 times 1 is 2. Minus 6 over 3. Yeah, negative 4 over 3. Okay, guys. Simultaneous, very, very important. Extremely, extremely important. Are we okay so far? Algebra in progress. I could send you a link of some of my algebra questions. I think I do have a few of them if you want. I'll just send you. Please practice algebra. Algebra in grade 11 is very key. Okay, exponents now. I have 2 to the power negative 1. We're going to look for the simplest ways of doing them. please guys, once I see a plus in the bracket, don't distribute, please. Best thing for me here, I think I will change this. 2 to the power negative 1 can be written as half. Look at that. Look at how simple life can be. That's what it means. 2 to the power negative 1, laws of exponents, is simply 1 over 2. And we can simplify that. They say without the use of a calculator. All right, the way I like to do this is I multiply this 1 multiplied by this 3, left to right, 3, plus this 2 multiplied by this 1. Since they said don't use calculators, they're asking you to show the steps. And then 2 times 3 would be 6. Diagonal, diagonal, denominator. Let me do that again. I start from the left top. 1 times 3, 3. It's a plus. Then go from left to right. 2 times 1, 2. Then at the bottom, left to right. 2 times 3, 6. Which gives me what? 5 over 6. Oh, now it's very easy to square. 25 over, done. I'm just reminding you of the things this was done in term 1. Oh, I love these ones. Exponents. My good learners, please change everything to prime base. Then life would be easy for you. All right? Change everything to a prime base. That's going to be kind of easy. Although I see something to do here which is easy. 2 to the power x. Look at this. What do you think this would be? Normally, this is the rule. Look at the rules. A to the power m times a to the power n. Same base. I'll keep the base and add the exponent. Right? But what if my exponents are the same? If my exponents are the same, what do I do? I'll multiply the base and keep the exponent. Very important rules. Check. The first one I wrote same exponents. The second one I wrote same base. Let me know if the rule makes sense. Remember what I told you? We're doing a lot of notes here as we go on. So if by studying that, I notice something that at the bottom, I can actually keep the numerator, the exponent, and multiply the base, which gives me 4. So I'm going to be smart. But otherwise, I'll change everything to a base of 2. Look at this. 2 multiplied by, this is 4 to the power x times 4 to the power 2 minus 4 to the power x times 4 to the power negative 3 over, multiply the bases, 2 times 2, 4, because they have the same exponents. Does that make sense? Now, if I check this, I notice something across the board. 4 to the power x seems to be common. So I'm going to factorize that. What do I have? 2 times 4 squared minus 4 to the power negative 3 over 4 to the power x. Do you notice that goes? Beautiful. Now 2 times 4 squared will give me what? 4 times 4 is 16 times 2. That's 32 minus 1 over 64. Again, okay, I don't want us to use calculators. So we need to do this smartly. But in this case, it's fine. You can use a calculator to just manipulate that because they'll think you multiplied. What is 32 times 64? See, I'm doing that again. It's called diagonal denominator. What is 32 times 64? You can use a calculator to cheat. I mean, they know that you can solve that one out by yourself. Somebody. Okay, let's not use calculators. But using an exam here, just use a calculator, please. Don't waste your time. 9 is 10. So what do we have? 8, 4. Is that correct? 1148. I feel something is wrong. 6 times 2 is 12. I knew. 6 times 3 is 18, which gives me 19. Yeah. 2048. Beautiful. But show that step. 2048 minus, which gives me 2047 over 64. Are we okay, everybody? So some places, but don't use decimals now. Decimals, you are telling the whole world that you use a calculator. So you can use a calculator, write down the answer, and move on. Okay, the last one looks very interesting, but don't get intimidated. Please, you need to watch this again. Is that okay? Watch this again. It's going to be available almost immediately. I'll make sure of that. 3 to the power negative half root of 12 plus, this is nice, root of 3, la 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 la. How do we change this? Let's take it step by step. Step by step. I'm going to leave the one outside. Please write nicely as well. What is the root of 12? If you check, remember they said don't use a calculator, but please, you can just use a calculator. It will give you 2 root 3, right? Check on your calculator, is 4 times 3, and let me show you how it works. The root of 12 is 4 times 3. Now this means root 4 times root 3. You don't need to show all of that, but that's how it works. So I'm trying to simplify everything. 2 root 3 plus. Now I want to remove this root. It's going to be 3. Let's take it step by step. Root 3 to the power of 1 over 3. I have removed the cube root. It's an exponent of a third. I hope that makes sense. I'll still keep this one. Let's see where it's going to lead us. Let's remove all the roots. This is 2 multiplied by 3 to the power half plus 3. Now, multiplied by 3 to the power half, 1 over 3. I hope that's making sense. I'm trying to do it step by step, every little step. 3 to the power negative half. Okay, I want us to go and simplify this. Same base, what do? We add the exponent. So 1 plus 1.5, half will give you 3 over 2. Now, multiplied by 1 over 3. I hope that makes sense. In the bracket is 3 over 2. Power for power, I multiply. What will this give me? 3 to the power negative half. Okay, let's go ahead. I don't want to jump steps. 3 over 2, this would cancel and give me 3 to the power half. Oh, nice. I don't know if you see this as like terms. Look, for example, if this is k and this is k, I have 2k plus k, which is 3k, because they are like terms. So what do I have? 3 to the power negative half times 3 multiplied by, so they are all multiplication. Or let me do this so that when you are going through, it makes sense. In bracket, 3 multiplied by 3. Now, since I am multiplying, what do? I add the exponents. 3 to the power 1. because negative half plus half would give me a 0. So my answer is 3. Beautiful. I love this paper. This paper is Are you okay? Please do let me know if anywhere I said something I don't understand. Please. And the best thing would be go over the paper again, go over the lesson again to make sure concepts are well understood. Like I'm doing more than, and I'm trying to break every step down, not jumping steps. I'm trying to work like you. Okay. You'd rewatched. Let me run. Solve for x. Oh, beautiful ones. I love these ones too. 2 to the power x, 3 over 4. First thing is I'll divide both sides by 2. Then write that as an exponent. 2 to the power 3. How do I get rid of my exponent? I would multiply by the reciprocal. You see, 3 over 3 becomes 4 over 3. Whatever I do on that side, I must also do on the side. This whole thing would give me 1. And the 3 would cancel the 3, 2 to the power 4, which is what? 16. X must be 16. X must be 16. 2.2.2. Oh, I love, guys, please, I want you to look at these ones. They are very, very important. Always split that. I'm doing this for the second time now today. Split it. It is times 5 to the power 1. Now, if you notice, if I put a wall here where the plus is, what do you notice? This side is common, that is common there, and that is common there. What's common? 5 to the power x. Now, in bracket, if I take this 5 to the power x, I must replace that space with 1. Please, not empty. It must be 1. Please, that's where learners also lose it. It must be 1. So 5 to the power x multiplied by 6. So 5 to the power x equals to 150 over 6. What would that give us? That is 2, 5. Which is 5 to the power 2. X will be 2. X will be 2. Sir, why is it 1 over 3? Which one? Which one, Kutlano? I just saw a message now. Please unmute yourself and take me back. Unmute and take me back. Let's stay with that. Talk to me. Huh?
I figured it out, so it's okay.
Oh, you figured it out?
Yes.
Sorry, I only saw your message now. Okay. All right, everybody good? Lino, are we on the same page? Lindiwe, are we on the same page? Sally? Same page? Tejo, Spey? All same page. Beautiful. Without using a calculator, beautiful. 9 minus root of 54. Remember, when they say without the use of a calculator, they want you to show your steps. Now, the simple thing here to do is to multiply this by 6 root 2 over 6 root 2. Or just root 2 over root 2. Don't worry about the 6. Just root 2. Just the root. You'll be fine. You will be fine. But you can use a calculator to give you an idea of what 54 is. I'll show you how to cheat. Okay. This is not a nice thing to show you, but I'll show you. I'll go and press root 54. 3 root 6. Now look at root 54. I want to show you how to cheat. Your calculator is giving you what? 3 root 6. I'll tell you what to do. Bring this 3 back into it, into the square root, but square it. Do you see what I did? I used my calculator to get the answer, then brought the 3 back. But when I'm bringing the 3 back, it must be squared, so that the square root of 9 is 3. Smart, ne? We okay? So there are so many ways. I could have actually simplified that. Wait, before I even do this, let's simplify that. So 9 minus, please show the examiner what you did, over 6 root 2. 9 minus square root of 9 is 3 root 6. Okay, what's common on top? 3 seems to be common. Right? Now 3 here 1, 3 here 2. So what do I have left? I have 3 minus root 6 over what? 2 root 2. Now this is when I'll come and say multiplied by root 2. And what you are doing is this. Let me write this nicely. You are saying root 2 multiplied by everything on top, because you are multiplying the whole thing on top, over 2 root 2. Nice. What is root 2 times 3? It is 3 root 2. Minus. Now, root 2 times root 6. I'll multiply the roots. That is root 12. The rule says root A times root B. Over. If you use a calculator, you can say that is 4. Can even use a calculator. But root 12, I've got a problem. Again, look at what I'm going to do. Root 12. Let me show you how to cheat. 2 root 3. So root 12. Oh, beautiful. If I'm taking the 2 back inside, I'll have to square it. It's 4 times 3. Show the examiner that you did that. 4 times 3, because you're looking for a perfect square. But what is the square root of 4? 2 root 3. Done. That's what they want us to show. I hope you learn my cheat. It will just help you. Okay. So it's much of algebra today, but I want to look at the guys, I looked at the parabola in our last lesson, so I don't want to go there again. I thought I'd be able to look at this with you, but I'll send you this algebra, please. I'll send it to you now. Just screenshot it and send it to you. You see, it's quite a bit of algebra here that I would love you to do, and I'll work out my solutions for you. Okay. But let's look at this hyperbola quickly. Did you guys do hyperbola in school? Unfortunately, some of you are writing so soon we couldn't get to it. Did you guys do hyperbola? Oh, specifically, why do we multiply? Specifically, is that your question? Why do we multiply by root of 2?
Yes, sir.
Okay, quickly. Let me quickly guide you there. We either rationalize or conjugate. Rationalization. Your calculator will not allow you to leave a root 2 at the bottom. So if I have that, your calculator will not allow you. So what we do is we multiply by root 2 over root 2, because that's 1. And if you multiply the top, what do you get? Root 2. Then root 2 times root 2. If they are the same number and the same root, just pick that number. Your calculator will not allow you. So that's called rationalization. Look, if I have 3 over root 3, I'll just come and say root times root 3. And this will be what? 3 root 3. Now, root 3 times root 3 is just 3. That will cancel, and that will give me root 3. Let's check on the calculator quickly. What is 3 over root 3? You see now. Your calculator would simplify it. It will not allow you. Make sense?
Yes, sir. Thank you.
All right. Then we also have what you call conjugate. Let me show you the conjugate. Conjugate is this, and we'll use a calculator to test. If I have 2 over 1 plus root 2, then your calculator will never allow you to have a root as a denominator. So look at what I'm going to do. Now, I am going to come here. This is more than one term, and say 1. I'll change the sign. You see, it's different from the first one. The first one, it was just one number, so I just multiply. But once I have 2, I'll multiply by the change of sign. What will this give us? This is saying 2 into bracket 1 minus root 2. And quickly, be smart. That is difference of 2 squares. I'll just say 1, the first times the first. 1 times 1 is 1. Minus root 2 times root 2. Please take note. It's the first and the first, last and the last. So if I expand, I'll have 2 minus 2 root 2 over negative 1. Oh, beautiful. My calculator will change the signs on top and divide by 1. So my answer will be negative 2, because this is positive. Remember, positive divided by negative, and then negative divided by negative. So your calculator may give you as 2 root 2 minus 2. Let's check. Let's check quickly. Sorry, I'm just racing for time. 1 plus root of 2. Do you see? Negative 2 plus 2 root 2. So conjugate and rationalization. Okay, I was asking a question earlier on and I think I missed your responses. Did you guys do hyperbola? How is that looking? I have 10 more minutes. I'm going to steal some few minutes from the grade 12 class because I have a grade 12 that some of them are also writing tomorrow. So I'm going to just steal 10 minutes for you. Okay, who's giving me a thumbs down on hyperbola? Give me that thumbs down again. Okay, you want to talk to me where you are lost on hyperbola? Where you are lost on a hyperbola. All right, I'm going to take that quickly, even if I don't answer the whole question, but I want us to look at that hyperbola. Minus 4 over x plus 3. Okay, watch this. Minus 4 over, the things they're going to ask you would be this. K of x. Things that you should quickly know on the hyperbola. Minus 4 over x plus 3 plus 1. What are the main points? Every other thing would be secondary, primary things. Number 1, asymptotes. Vertical asymptote. The vertical asymptote, you'll be talking about your x. So I'll say my denominator is equal to 0. Therefore, x equals to negative 3. Use this to remember VAX. Vertical asymptote is the x. Denominator is equal to 0. What about your horizontal asymptote? They will ask you all of this. It's just your Q value. You don't change the sign. So that becomes my asymptote. I want us to go step by step. Are you okay with asymptotes? We're going to go step by step together. Asymptotes, we're good? Okay. Number 2, x-intercept and y-intercept. Oh, before I move on, let's talk about domain. You see say x is an element of real numbers, but x should not be equal to your asymptote. See your minus 3. You say x should not be equal to that. Your range, you do the exact same thing. Y is an element of real numbers, but y should not be equal to your asymptote. Second concept done. First concept, asymptote. Second concept, domain and range. Third concept, intercepts. Same story. Y-intercept, x should be equal to what? 0. So y, negative 4. My x is now 0. You put that in a calculator and get your answer. What would your answer be? What would your answer be? 1 minus 4 over 3? Negative 1 over 3, I think. Somebody confirm for me? What about your x asymptote? Your y will be equal to 0. So I'll say 0 equals to. A lot of learners don't know how to do this one. They make mistakes. Please watch what I'm going to do. 3 steps. I'm going to start by moving this one over here. Negative 1. That's step 1. Step 2. I do something crazy here. I'm going to move this here and move that there. X plus 3. I'm just switching places. Negative 4 over negative 1, which is 4. Now move the 3 over. Let's write it as a coordinate. X is 0. And here, x is 1. Please let me know if we are on the same page. Intercept. For y, no matter the function, y-intercept, x is 0. X-intercept, y is 0. And then you solve. Thank you, basically, negative 1 over 3. Beautiful. All right, done. Axis of symmetry. These are basic things they're going to ask you. Now, here's your equation. Whenever I want to do my axis of symmetry, I'm going to cut out the A. And then I'll put a bracket here, plus or minus. The axis of symmetry, there are 2 of them, with a positive gradient. Please, you need to learn this quickly. We didn't have time. I'll use the one with the plus, and then I'll solve. The one with a negative gradient, it means in front of the bracket I'll be having that. Axis of symmetry. Just put a box, cut the A out, and you're done. So for this one, my answer for the examiner will tell you which one they want. But remember, I am cutting this out quickly as possible. Cut out the negative 4, put a bracket here, and put plus or minus. So y equals to plus x plus 3. Oh, this one, the plus would not have an effect. X plus 4. And if I want the one with the negative, the examiner would be specific. Then in front of the bracket, it will be negative. And then you simplify. Remember, you distribute the negative. 1 minus 3, minus 2. Axis of symmetry with a positive gradient. Talk to me, are we okay with this page? Everything on this page? In grade 11, this is the bare minimum that you should know. Is there anybody who's lost? Now we want to sketch a graph. We want to sketch the graph. Sketching the graph. How do I sketch my graph? I'm going to use all the values that I have gotten so far. Please look at it quickly. I'll start with my x and y. Let's use a white. Then I'll start with my asymptote. X equals to -3 and y equals to 1. X, we use dotted lines. -3 is somewhere there. Don't draw too far. All right? -3 and y equals to +1. Asymptotes, you use dotted lines. Y equals to 1 and x equals to -3. That's where I start from. First, you draw your asymptote. Secondly, you mark off the points that you have. X-intercept. When x is 0, y is -1/3. -1/3 should be somewhere here, because that's 0. So my graph must pass through that point. Then, when x is 1, y is 0, my graph must pass through. I want to show you something. Okay, I already see what my graph should look like. Look at what I'm going to do. Don't force those points. You see, just mark them so that your graph is easy. Look at what I'm going to do, everybody. My graph must pass through here and here. Don't worry. See, I'll go to my graph. It must pass through there and there. Okay. Now, if I see that I'm missing the point, I'm just going to clean that and put my 1 there. Your graph must move towards the asymptote, but not touch the asymptote. And once I do this quadrant, I must also come here and do the opposite quadrant. And that is my graph. If I was drawing in this quadrant, then I'll draw it's both opposite quadrants, my good learners. Opposite quadrants. And by the way, this is your axis of symmetry. I want to show you something nice. We did this equation a while ago. Axis of symmetry with the positive and the axis of symmetry with the negative. So I'm going to label it AOS negative gradient. AOS positive gradient, because it's moving to the right. Our equation was y equals to x plus 4. Negative x minus 1. It makes sense. That's my minus 1 there. And that's my positive 4 there. And this point, please look at this point. Do you notice your x value is -3 and your y value is 1? Those are your asymptotes. So it's about the points. It's about the points. Okay, guys, I'm going to have to shut down now. But before I shut down with you guys, very tricky something here. If you equate, you can just take a picture of this, the two axes of symmetry, you will have the equation of the asymptotes. I want you to see the way I'm going to manipulate this. So some examiners would come and tell you, okay, the axis of symmetry equations are y equals to x plus 4 and y equals to what? Minus x minus 1. Look at what we are going to get quickly. If I take those two equations, stop writing, you just take a picture. If I take those two equations and equate them, x plus 4, I want you to see what the x value I'm going to get. Bring that x over, it becomes x plus x minus 1. Wait, what is our axis of symmetry here? Oh, it's minus x minus 2. Yeah, I can see that it's not working. Minus x minus 2. Sorry. I want you to see where we are going. So they'll give you these equations and tell you to find the asymptotes. Check. 2x. What is x? Do you remember? Minus 3. And then you can find y by using any of the equations. Do you remember? Y equals to 1. I hope this little crash course will assist you. I've got more lessons. I'm just going to look for them for you now, and especially on graphs. But please, for those of you writing tomorrow, get papers. Do you have papers? Or do you want me to send? I could send 2 or 3 for you. All right, I could send them for you. Specifically, how is it marked? I'm not sure which question you're asking now. Don't worry about how it's marked. Just get answers and show all your steps. Let me send 2 or 3 for you, okay? Please, if you are lost, for the first time, let's use the group. You are all on the maths group. Guys, help me with 1.1. Help me with this. And when they ask for help, let everyone respond. Let's be our brother's keeper. Some of us are writing tomorrow. They need all the help that they can get. So please don't be selfish with information. Let's help each other out. Unfortunately, I have to go to the grade 12 class now. Some are also writing tomorrow. But I'm with you all night long. So once I send you 2 papers, please listen to the instruction. I'm going to send you the papers. The papers are going to come with memos. Look at the question, answer it, look at the memo, mark it. If you don't understand what the memo is saying, take a screenshot, send it on the group. Let's all look at it there. While I'm busy, somebody else could help, and I'll also be checking throughout the night to make sure we are okay. Would that be fair enough? And even if it's not a question that I send, you are studying on your own, you have other materials, you get stuck, you don't know the answer, please share. Once you share the question, let everybody get involved. The more you help someone, the better you'll also understand. Thank you so much, guys, and love you all. Good night. This lesson is going to be available now.